So we're going to look at number 10 now. And when you look at number 10, you're told that you're making a fenced-in area that has two separate regions. So what that means is now when you draw your picture, you want to draw your picture in a way so that you have one large field, and then you divide that in half. So my widths are still the entire length of the pens. And my length is still the heights. But what happens is this is also length L, cutting it in half. No, like the width is always this whole like region. If you wanted to, you could make this W and that W, but then when you made your dimensions, your whole dimension would have to be 2W. So you're better off keeping it the entire outside length and not thinking about the fact that it's being cut. And that's what I was saying. That like you don't want to take into account that it's being cut. So the perimeter is now 2W, but the length of fencing that we need to utilize is 3L instead of 2L. Because you have to incorporate the fact that it uses fence to make that line in the middle. So I believe you're given 800 feet of fencing, or 800, or yeah, I was looking at number 9. So your area is still length times width, and you're given that the area of the region has to be 216. Exactly. Like I found W, so I could get rid of my L's. So I said W equals 216 over L. And then I plugged 216 over L in. No, I didn't. I kept my L's for W. So I said my new perimeter is 2W, no, 2 times 216 over L plus 3L. Yep. So pretty much once you get to this point in all of the optimization problems, whatever you're trying to minimize or maximize is going to involve a derivative. Exactly. So I'm going to find P prime, in this case is negative 432 all over L squared plus 3. And think about the fact this L would be brought up as a negative 1, so that's where I get the negative 432. I subtract 1 away, so I get L squared, and then 3L becomes 3. Exactly, I say this as an L squared, so I'm going to get myself negative 432 plus 3L squared all over L squared, so that I can combine them into one fraction. And then I say my numerator equals 0. And my denominator equals 0. I don't know, 432 divided by 3, it has to be 144, because the square root is plus or minus 12. I just wrote down plus or minus 12. So again, cannot have a negative length. We cannot have a 0 length. So what that does is give the only true working answer to be 12. I can plug it into area, or my already solved for and just do 216 divided by 12 and get 8. And then this was meters. So when it asks for your dimensions, I just wrote 12 meters by 18 meters. The variable with which it is doesn't matter so much, because if I had flip-flopped my L's and my W's on my perimeter, I would still get the same thing. I just would have gotten them in the reverse order. So, exactly. So that's why sometimes it doesn't ask for like the length and the width.
Right.
It asks for the dimensions. Because your variables are interchangeable unless they gave you a diagram with the variables drawn in. Let's look at. Go ahead, what? Yeah, we can do the worksheet one if you want. Sure. Anybody want to guess on what they got for the worksheet one? It was A.
I took it through and then you have to take a secondary.
You don't. You could. You need to use the distance formula.
Yeah, I use that.
So, yep.
Yes.
So your distance formula was D equals the square root. So you had x minus 0 squared plus, and then instead of writing the letter y, you put in 3 minus x squared. And then you put in minus 1 squared. Okay. And then did you do what I did, which was to throw the square root to a squared, or did you leave it as a square root? Okay. So then you have d squared equals x minus 0 squared just becomes x squared. And then in here, did you clean it up? So did you say, okay, 3 minus 1 is going to be 2. So then you have plus 2 minus x squared squared.
Yeah, I got all the way.
Okay. So when you derive, you would have 2d times d prime. And then you got 2x plus 2 times 2 minus x squared times negative 2x. Okay. I was saying, did you cancel all your 2's? So this 2, did you cancel an extra 2? Or did you made sure you kept that one? Or at least one of them? Did you keep this one? Or you took both away? And that, I bet that's why you were probably close but couldn't get the. Oh, you flipped your negatives. But by doing that, you probably didn't have a negative here. So it will counteract, right? Because if you think about if I would distribute that in, that's going to make this negative and that positive. No, because if you think about it, like this is really a 4. Because it's 2 times negative 2. There needed to be like a plus sign here instead of a minus. So we would get d prime equals 1 over d times the quantity x plus minus 2x times 2 minus x squared. So I would distribute this in. So you have 1 over d equals x minus 4x plus 2x cubed. Okay, I'll get you something to write with. So the reason that like I keep writing the 1 over d and not caring so much about that is because being that it's 1 over d, if I set this equal to 0, that d is going to be in my denominator. So that's why like I did, like, you know what I mean? It's really like all of this written on top of all of that. So when you set this equal to 0 now, you're going to get 0 equals, I would pull that x back out. So I have -3 plus 2x squared. So I get x equals 0 and x equals 3 divided by 2, all in my square root. So that's where you end up getting the a, because you get the 6, the square root of 6. Because like you would just move your 3 over, divide by 2, and then that's underneath your radical. They just rationalize the denominator. So they multiplied by 2 over 2. So they got plus or minus root 6 all over 2. It is. Trying to solve for it to determine if this was an extrema. Just take your sec. Because remember how I told you there's that irrelevant second derivative rule? That like if the second derivative is always negative, then like your first derivative's a max and stuff. That's what that guy was doing. But really, if you got your critical points, the reason the denominator is irrelevant in this case is because those are going to be where it doesn't exist, which are not going to be. You mean up top, just how they got rid of this? So again, like what I was saying is the reason I know I don't have to solve for this equaling 0 is because of the fact that this is a square root in my denominator. So the minute I drop that down and I solve for it, if I get a 0 on this, it's either going to be outside my domain of the square root, or it's going to be a DNE. It's going to be an asymptote. Mm-hmm. Yeah. I'm sorry. Yeah. You should have just sent me a message on Remind. I would have just done the problem and like posted it to you.
Okay, so you get someone.
Right, because it's going to give you a vertical asymptote absolutely every time. More helpful. And okay, so then my next part is I was going to say the reason I know it's the positive square root of 6 over 2 instead of the negative square root of 6 over 2 is because the point they gave me was 0, 1. If it was 0, -1, it would have been the negative. I picked the critical number closest to what? Because the point they picked is on the axis of symmetry, so they're exactly equidistant. But if it wasn't on the axis of symmetry, then that's my like second hit. Yeah, I wasn't thinking about the fact they picked it on the axis of symmetry. Let's look at, so we the bell kind of cut us off on the inscribing the rectangle one.
Yeah.
So and I said it's probably very close to pi fourths. So pi fourths as a decimal is like 0.78. If you did it on a graphing calculator and you found the zeros, it was 0.71. So it was relatively close to pi fourths. So again, like that's understanding the sine curve. I could relatively figure out, okay, my critical points are probably going to be very, very close to the unit circle value. So we'll go back, we'll finish that one, I'll show you. We can do any other problem you want on that, yeah.
Can you just tell us
Can
can you just tell us the letter answer?
2 was B,
Oh, I was born on.
3 was D,
I got that.
and 4 was B.
Yeah, I got it. So for 3, I don't know how to solve it without just plugging in. Yeah, I know, but then if you do the surface area one, if you do surface area of all of them, one that gives you the least to the track.
Okay. So,
Without plugging into that, I don't know.
yeah, and again, and that's kind of like part of this too, like that's, you're trying to think in terms of area. So like if you were going to do it where it said what dimensions should be used to create an aquarium for this amount of glass, if you're right, like you pick the one with the smallest dimensions. The problem is you don't know how to do it without multiple choice. So in our notes is actually one like this again, but this is very, very similar to the box that I had you create. So once again, when you draw this one, you would draw it the same way I drew the box that you created. So we took a sheet of paper, right? And we cut out the corners to maximize volume. So in cutting away the corners, my paper in front of me should have looked like this, where these lines here represented the creases. So when they tell you the engineers are designing a box-shaped aquarium with a square bottom. So, right, like you see how all of their options have 2 of the same numbers? When I label this, I would label this and this as X. So eliminate length and width and go to both X's. The fact that it's an open top is also critical. If it was a closed top, I would need a second X by X region attached to this drawing. But again, being that it's an open top box, I don't need that space. Now, the only other thing, I have to pick a dimension to represent height. So our next favorite variable besides X is usually Y. So all of these represent height Y. Because again, the aquarium has to be the same height. You're not going to have an aquarium with different heights because then the water is going to pour down. So the height is going to be Y. Then it says, what dimensions should they use to create an acceptable aquarium with the least amount of glass? So when you talk about this, we can talk about the fact that we know what? What piece of information do we know? What's that 2048 represent? So volume, in this case, is length with height. So volume would be X by X by Y. So 2048 would equal X squared over Y. And then X squared equals. Well, I'm jumping to my next point, which is you're going to pick one of these variables to solve for. So Y is going to equal 2048 divided by X squared. Because what that's going to give me a choice of doing is finding my surface area and then eliminating a variable from the surface area. Surface area. Because you're trying to minimize the amount of glass you're utilizing. So surface area, well, I was going to say take it slow. Like you need the surface area of the base. So the area of the base would be X times X or X squared. Now, because this is a square, all 4 of these will be the same. Surface area by definition is usually the area of the base, the area of the two sides, and the area of these two sides. That's my thing. So in this case, yes, it will be 4x, y, because all of those are the same. Okay, so that's where you need to take this and plug it in for y. So you eliminate a variable. So 8,000 plus 4 times 48. So 96 and 96. What? 192?
I can never figure out.
2048. I noticed. I tried, but I could never get it down to 1. So as long as you never swipe in one direction.
That's the idea. Because once you start down backwards, you want to keep the big number in the bottom. Or in the top. I think it wants
Okay, so take your derivative. Derivative of x squared is?
2x.
Derivative of that, again, you don't have to even really multiply this just yet. So it'd be negative 4 times 2048 all over x squared. Because this is like an x to the negative 1. Every time you have an x in your denominator, it's going to make the numerator a negative and add 1 to the denominator every time. So find your common denominator. Yeah, but you're going to divide it by 2 and then cube root it. So it's only 2 times 2048. It is. Divided by, or cube root of that. Cube root of 8,000.
Are we allowed to use that calculator?
No, but it's 16.
So without a calculator,
You have much like 20.1. Wait. That's not right. No, hold on. I lied.
Yeah. Yeah, you took the cube root of 8,000. So again, you got to this point. So you would end up getting x cubed equals 4 times 2048 divided by 2. I would expect you to be able to figure out, okay, that's 2. So then 4,048 or 4,096 rather. So no, what I was going to say is take logic into perspective. If 20 is going to give you a 400, so like 20 squared is 400. Now you have to take into account cubing that. So like 20 cubed would have to be way bigger than 4,000 because 2 times 2 times 2 is going to be 8. Like just go back, like even eliminating this and just think about your cubes without the thousands. Just go back to your basic cubic ideas and knowing that 2 cubed is 8, 3 cubed is 27, 4 cubed Any guesses?
Uh, And that's
If you don't have a calculator, that's the best way to go about it. What I was getting at though is that you can take like these basic understandings to get you to that 16, break 16 down into 4 and 4.
what do you want to talk about?
I can't promise you either way. A lot of the problems are non-calculated.
Just like the one